It's interesting, this idea of the Big Bang created the universe. That's what Einstein's theory says. That's textbook cosmology, if you like.
This is a time capsule from the birth of everything, and it was taken just a few days ago. Scientists using a powerful telescope in Chile have captured the most detailed image of the baby universe, revealing secrets locked in time itself. This is a cosmic turning point. Buried in this ancient light are answers we were never supposed to find. Welcome to Space Aquarius, and let's dive into the unknown. To truly see the birth of the universe, scientists needed more than just a powerful lens. They needed a telescope that could do something extraordinary. That's where the Atacama Cosmology Telescope, or ACT, comes in. Tucked high in the mountains of northern Chile, ACT sits at an altitude of 17,000 feet above sea level. That's higher than most commercial planes fly. Why? Because up there, the atmosphere is thin, dry, stable, and crystal clear. It's the perfect spot to observe the cosmos without the interference of clouds, moisture, or atmospheric distortion. But what makes ACT truly different isn't where it is, it's what it listens to. Unlike the telescopes that take stunning pictures of galaxies in visible light, ACT doesn't actually see the universe. It detects microwaves, the faint, ancient radiation left over from the Big Bang. These microwaves are invisible to the human eye, but they carry the fingerprints of the universe's earliest moments. ACT is what scientists call a ground-based millimeter wave telescope. It's designed with extreme precision, scanning the sky night after night, not for stars or planets, but for subtle ripples in the cosmic microwave background. Over the course of more than a decade, scientists using ACT collected and processed over 90 terabytes of data. That's the equivalent of about 23 million high-res photos. And every byte of that data was another piece of the puzzle, each microwave a whisper from the earliest days of existence. It took teams of researchers from around the world, working across disciplines, to turn that raw data into a high-definition map of the ancient sky. A view of the universe not as it is, but as it was, just moments after it all began. So that begs the question, why haven't we seen the beginning of the universe until now? What was so special about this telescope? Before we move on to the next section, please subscribe to Space Aquarius if you've liked the video so far. We've all heard about the Big Bang, the colossal explosion that marked the beginning of everything: time, space, matter, and even the laws of physics. According to the leading theory, the universe burst into existence roughly 13.8 billion years ago. But for all our technology, for all our telescopes pointed at the stars, we've never actually seen those first moments. Why? In the earliest seconds of the universe, it was just chaos. Blindingly hot, incredibly dense, and completely opaque. Light didn't even exist in the way we know it. Everything was so tightly packed that photons, the particles of light, couldn't travel freely. They just bounced around, trapped in a cosmic pinball machine of particles. It wasn't until around 38,000 years after the Big Bang that things cooled down enough for light to finally break free. This moment, called recombination, is when atoms form and the universe becomes transparent for the first time. That first light, it's still out there, echoing across space, stretched thin by the expansion of the universe. Today we know it as the cosmic microwave background, or CMB, the faint afterglow of the Big Bang. Think of it like the universe's baby photo, except instead of colors and smiles, it's a map of tiny temperature fluctuations, just millionths of a degree different, frozen in time. These fluctuations hold the blueprint of everything that would come after: galaxies, stars, planets, even us. And for decades, scientists have been trying to capture that image in greater and greater detail. Because buried in that ancient light are the answers to some of the biggest questions we've ever asked. And these form what we now call the baby pictures of the universe. After years of scanning the skies and crunching massive amounts of data, scientists using the Atacama Cosmology Telescope finally unveiled what some are calling the most significant image in cosmology since the discovery of the Big Bang theory itself. It's the cosmic microwave background map, a sprawling, intricately detailed snapshot of the universe as it was just 380,000 years after its birth. And this isn't just an upgrade, it's a revolution. The image ACT produced is twice as detailed as previous versions, surpassing even the data collected by missions like WMAP and Planck. Every pixel of this map tells a story about the earliest structure of reality itself. But let's talk about what you're actually looking at. At first glance, the map might look like an abstract heat map, a strange blend of blue, orange, and red splotches. But those subtle colors represent something profound: minute temperature fluctuations. differences of just millionth of a degree across the sky. These tiny shifts aren't random noise, they're the first whispers of structure in the cosmos. What you're seeing are density variations, areas where matter was ever so tightly more or less concentrated. Those fluctuations, barely noticeable, would later evolve into galaxies, stars, black holes, and every cosmic structure we know today. Even more mind-blowing, embedded within these patterns are quantum ripples, echoes of fundamental uncertainty from the universe's first fractions of a second. It's as if the cosmos kept a record of its own formation and hid it in plain sight. With stunning overlays and animated data layers, scientists can now trace how the early universe expanded, cooled, and started to take shape. These visualizations are more than art, they're a scientific time machine, offering us a direct line to the beginning of everything. This isn't just a pretty picture, it's the oldest light in the universe, finally rendered in high definition. As scientists dug deeper into the data from the Atacama Cosmology Telescope, they uncovered something extraordinary, something that reshapes how we think about the very fabrics of reality. The ACT data confirmed, with stunning precision, that the universe is flat. Not flat like a sheet of paper, but flat in terms of its geometry, its structure on the grandest possible scale. And that might sound abstract, but it's one of the most important questions in cosmology. What shape is the universe? For years, there had been debate. Earlier measurements from the Planck satellite had hinted that the universe might be closed, slightly curved like a sphere. That kind of universe would eventually stop expanding and collapse back in on itself, ending in what physicists call the Big Crunch. But the ACT results tell a different story. They show the universe is geometrically flat, meaning that parallel lines would remain parallel forever, even across billions of light years, and that flatness has enormous implications. A flat universe is exactly what we'd expect if the theory of cosmic inflation is correct. That in the tiniest fraction of a second after the Big Bang, the universe expanded faster than the speed of light, smoothing out any curves or edges. It's a theory that helps explain the universe's incredible uniformity, and ACT just gave it a major boost. But even more profoundly, a flat universe doesn't just support inflation, it points toward a cosmos that will keep expanding forever. No edge, no boundary, no final wall. Just an endless stretch of space, cooling, spreading, and evolving long after we're gone. And as one scientist put it so perfectly, we've essentially confirmed the shape of everything by studying the echoes of its birth. In other words, by listening to the faint hum of the early universe, we've learned not just how it started, but how it will likely end, and that changes everything. The data from the Atacama Cosmology Telescope didn't just give us a clear image of the early universe, it's reshaping our understanding of how everything works. For years, scientists have debated the Hubble tension, conflicting measurements of the universe's expansion rate. But ACT's ultra-precise data has narrowed the uncertainty, placing the expansion at around 67.6 kilometers per second per megaparsec. It also confirms the universe's age at about 13.77 billion years. This isn't just about numbers. It tightens our models for dark matter and dark energy, those mysterious forces that make up over 90% of the universe. And it paves the way for what's next, the Simons Observatory and CMB-S4, telescopes that will dive even deeper into the universe's first moments. We're not just refining equations, we're edging closer to the ultimate question. Why is there something instead of nothing? With each breakthrough, we're no longer just observing the cosmos, we're beginning to understand it. If we can now see the moment the universe was born, does that mean we're one step closer to proving how everything began without needing a creator? Let us know in the comments below. Don't forget to subscribe to Space Aquarius for more cool videos about our universe.